好，那我们就是邀请他很久啊，然后就终于说有一个机会这样子啊，让他来为我们演讲一下。那等一下他也会就是现场的 live 回答问题。那因为他讲的内容很多，所以大家可能要练一下音听哦。那我就废话不多说，我就直接按开始哦。
Hello everyone, my name is Evan Yo, and today I'm going to be talking about Vue 3, behind the scenes of a major rewrite, and we'll talk about some ins and outs of the process of rewriting Vue 3, and also talk about some of the challenges when we are working on major rewrites of a popular open source project. And hopefully this will shed some light on what went through behind the scenes. And so let's get into it. So first of all, let me introduce myself. My name is Evan Yo. My Chinese name is You Yuxi. I was born in mainland China, but now I work and live in the United States. And I'm now an full-time open source developer. And I've been doing that since February 2016. So that's more than 4 years now. My Twitter handle is @YouYuxi, and my GitHub username is @YYX90803. It's probably easier if you just look for the Vue.js repository and you'll see all my commits there. Okay, so first of all, I want to talk a bit about what's new in Vue 3. I don't know how many of you are front-end developers, how many of you have actually used Vue. So I'll be a bit more generic. But if you're not a front-end developer, don't worry. Just skip the parts that you don't really find making sense. So first of all, the rewrite of Vue 3 for us maintainers, the biggest benefit is it's now much more maintainable because we switched from plain JavaScript to TypeScript. Actually, we switched from Flow to TypeScript. And we now use a much more modularized internal architecture to better separate the internals. Obviously, a major rewrite ought to make things faster. Otherwise, if you make things slower, it just doesn't make sense, right? So when making things faster, we actually attack from two sides. One is we rewrote Vue's reactivity system with a proxy, the ES 2015 proxy, which is a new language feature in JavaScript. And we also completely redesigned the whole compiler to rendering pipeline, so that we now use a strategy what we call the compiler-informed virtual DOM to get the best possible performance without compromising on the lower level capability of digging into the virtual DOM and expressing rendering logic with plain JavaScript. And we also make your built bundle smaller by making the global APIs tree shaking friendly. And we also expose compile time flags to allow you to turn off certain features that cannot be tree shaking, but automatically tree shaken, but can be explicitly turned off so that you can drop them from your final bundle. We also introduced a whole new set of API called the Composition API to make Vue scale better in larger applications. And finally, we're introducing a lot of quality of life improvements to provide a better development experience, specifically in single file components. Okay, so we'll dig a little bit more into each of these. For TypeScript, we were largely, there are two aspects of switching to TypeScript. The first aspect is internal. In Vue 2, we were previously using Flow, but if you've used Flow, you probably know as a Facebook project, surprisingly, it's not that well maintained publicly. As a public open source project, they don't really listen to a lot of feedback. They don't really put the open source users as their first priority. So unfortunately, TypeScript is doing a much better job at that. So we switched to TypeScript. And also another reason is much better IDE support in VS Code. So that makes large scale refactoring much easier and safer for us. Now, externally, we are also seeing an increasing demand to better TypeScript integration from Vue users. We have more and more users trying to use Vue with TypeScript, but the TypeScript support in Vue 2 was not so satisfactory, largely because we only added type support at a later stage when Vue 2 was already kind of finished. And that result is we are manually maintaining the type declarations, and some of the internal APIs simply wasn't designed with TypeScript in mind. So Vue 3 is set out to change all of that. To provide better TypeScript integrations by using TypeScript ourselves, so which also allows us to generate the type declarations directly from our source code. So that brings more consistency, less maintenance burdens, and better development experience. The modularized internals now splits the Vue internals into separate packages. So now if you install Vue 3 from npm, you'll notice that it actually has dependencies on @vue/compiler DOM and @vue/runtime DOM. So each box here is actually a separate package. But in the repository, they're all put together in a single repository as a monorepo. But each of them has its own API contract, its own README, its own test suites. So the better decoupling allows people to be able to understand the code base better and also more confident in changing things in a certain submodule, because you know the changes are better isolated and better decoupled from the rest of the framework. We rewrote the reactivity system using proxy. Proxy is a ES 2015 feature. So when we started playing around with the idea, So proxy was introduced in ES 2015, and unfortunately, it only became somewhat universally usable in the past year or so. So it took a few years to catch on, but we were thinking about this the moment it was introduced in the ES spec, to be honest, because it addresses some of the limitations of ES5. In Vue 2, we are currently using ES5 getters and setters to detect state changes in your data objects. It works in Vue 2, but it has some limitations. There are certain cases that we simply cannot detect. So those are what we call caveats that we have to explicitly document, and users have to be aware of that. In Vue 3, we got rid of those caveats thanks to proxy, because proxy provides much more complete language coverage. It also gives us better performance, and the reactivity conversion is also lazy by default. So that gives us a lot of benefits. And then in the rendering part, there is a strategy what we now call the compiler-informed virtual DOM. So if you've used React, you know React uses virtual DOM. If you've heard of Angular's latest compiler called Angular Ivy, and also Svelte 3, they both compile templates into something we call instruction sets, so kind of like imperative commands that directly work on the DOM. So these are two very different strategies, and Vue is somewhere in between, because Vue has a compiler that compiles templates, but it also has an underlying virtual DOM implementation that is used for the runtime updating of things. On the first look, if we were to go the full compiler-based route, and as you can see in this example that I'm showing right now, when we look at the template, we instantly know that there's only one thing that could potentially change in this template. So this is what I mean by the template, because it's so restrictive and so statically analyzable. It gives us a lot of information on what can be optimized and what cannot. So the advantage of a pure compiler-based approach is that you can generate extremely efficient code to render the view and to update the view, because you get the utmost control. But the downside of that approach is that the generated code is untouchable by the user. So the user can't really manually write all that of code, nor can they actually hook into that process to do some sort of transformation at the view layer. So that is what the virtual DOM allows us to do. If you've used React, you know how powerful it is to be able to express part of the UI as a set of objects, right? You have a virtual DOM tree object that represents a piece of UI, which you can pass around, you can transform, and you can inspect to do a lot of interesting stuff. So this capability actually offers a lot of flexibility when it comes to advanced cases, especially in authoring complex UI components that's intended to be reused or be as flexible as possible. So this is an important capability that virtual DOM affords that we don't want to give up. So the challenge is, can we get the best of both worlds in Vue 3? And the answer is yes. So we somehow managed to do that. So the result is what we call the compiler-informed virtual DOM. The first step is the compiler will take your templates, compile it into a virtual DOM render function, but it's specifically optimized using the compiler-only information. It will leave some hints into the runtime so that when the runtime diff algorithm detects those hints, it can take the dedicated fast paths to skip all the unnecessary work. And in the case of when the user decides to forego the template and drop down into raw virtual DOM, they want to manually write their own render functions, the algorithm will detect that too and fall back to the full diff mode. So this allows the user to mix both, mix template compiled, more optimized virtual DOM render functions in the application, which will probably make up the most of your application. But at the same time, you can also mix some handwritten render functions for advanced use cases or third-party UI libraries into your code base. And they'll just work nicely together. So you get the best of both worlds. If you're interested, we have a link called the Vue template compiler. And as you can see, we have, this is the exact snippet that we were showing just now. And let me move this around. So as you can see, when we generate the thing in normal mode, you notice that we're creating something called a block here. And these nodes are what we call static nodes. And this node is what we call a text node, because it has dynamic text inside. So at the runtime, only this node will be considered dynamic. And if we turn on this hoist static optimization, you'll notice that all the static nodes are now hoisted outside as static. They're constants, right? And we just use the same constants on every render. And the only dynamic part is this. And only this node will be tracked and diffed against during updates. So we are essentially skipping all the static parts on subsequent renders, which is huge. Now going back to the next part, so we handled the runtime updates, but we can also leverage the compiler for server-side rendering as well. So what we call the compiler-informed SSR is, again, let's go back to our example here, and we can toggle this option. Oops. Let's toggle this option and turn it into server-side rendering mode. And now you can see a lot of the static parts are now concatenated into plain strings. And you can ignore this part because this is just edge case handling in case the parent sends in additional props. But this is the only dynamic part in the original template. And everything else is just concatenated as plain strings during server-side rendering. So imagine this compared with generating the virtual DOM first and then serializing everything. The performance is also hugely different. So this is what I mean by keeping the flexibility of the virtual DOM, but still we can leverage the compiler to generate code that is much more optimized. And the most challenging part is actually building a system that can handle a mix of both. And we do that on both the client runtime and on the node server-side rendering runtime. So both sides will able to handle the mix of compiler-optimized parts and also manually written parts. And we also leverage the compiler-generated information to do more efficient hydration on the client as well. Okay, so that's about performance improvements. Now let's talk about size. When it talks about front-end frameworks, it's often important to be aware of how much weight a framework is adding to your application. Right? So Vue has always been considered to be relatively lightweight. Angular is known to be quite heavy. React is getting heavier and heavier, mostly because of the new Fiber runtime, which is very runtime heavy. It's probably around like 40-ish, 30-ish KB gzip, almost 40, I think. But with Vue 3 has always been around, Vue 2 has always been around like 23, 24. So in Vue 3, the runtime size with all features included is approximately the same. 22 KB, that is with minification and broadly compression. What tree shaking means is that all these APIs are now exposed as global imports using ES module import syntax. The benefit of using ES module import syntax is that the imports are statically analyzable. So an advanced modern bundler like Rollup or Webpack can analyze these imports. And notice that some of the exports from Vue are never used. And at build time, it'll be able to just simply drop all the parts that isn't used. So that's what's called tree shaking. So after tree shaking, the minimal hello world app in Vue 3 will clock in at around 13 KB with minification and compression. We also have something called compile time flags that allows you to further customize your build. So you can, for example, you can turn the Vue options API flag to false, which will drop the options API support so that you only use composition API. And the benefit of that is you'll shave off another around 2 KB of your final bundle. Now this is pretty lean now, right? Some of you may know frameworks like Svelte. It can generate even smaller runtime size for hello world apps. So an interesting fact is the strategies that Svelte or Angular Ivy is using typically results in more verbose runtime code compared to virtual DOM. So interestingly, for a component of the same size, for a template of the same size, Vue generated virtual DOM code will be approximately 50% lighter than the Svelte equivalent. So when you have a lot of components, the final bundle size actually gets closer and closer. And eventually, you'll have a smaller app when you cross the 40 to 50 components threshold with Vue. So some of the trade-offs are made in this. It's right, as you can see, it's not a which one is absolutely better than the other situation in terms of bundle size. So I just want to emphasize that there is a trade-off that's being handled in here. Now, we also introduced some new single file component features like script setup, which is syntax sugar for using composition API in single file components, and style vars, which is stage-driven CSS variables injection into single file style blocks. So we have, I won't dig into too much details about these. So if you use Vue, you can go to our RFC repo, which have more details on these. But these are just some more exciting new stuff that's just came out recently. So I want to mention it here. Script setup allows you to, inside this Vue single file component, you can author your component logic as a JavaScript model. And everything you export here is considered exposed to your template. So that makes using composition API very ceremony-free. So it just like strips off all the unnecessary stuff that you have to write, and you just focus on the logic with composition API. And this is done through a compile time transform that transforms this into actual normal composition API usage. It even works with TypeScript. So that's a big plus in this aspect. And accompanying the launch of Vue 3, we also worked on a new tool called Vite. So Vite is French for fast. And this is a new build, next-gen web dev build tool. It uses a dev server that leverages native ES module imports in browsers. So the browser can already, most modern browsers can actually already handle native ES module imports. And when you do that, you can actually skip transpiling your source code that's using ES module imports and let the browser do the import, the actual imports of each file. And the server will intercept these imported requests. If the imported item is not JavaScript, for example, you're importing CSS or you're importing a Vue single file component file, the server will notice these requests and transform the files on the fly and send them back. The result is you don't have to do the typical bundling process before you can see your app running. And it's blazing fast. We also built hot module replacement on top of this. And if you compare this with Webpack, you'll notice that the server startup time and the hot module replacement responsive time is just orders of magnitude faster. So you have to try it out to get how fast it is. And for production, it uses Rollup to produce very efficient production builds. And it's all pre-configured. So for most apps, you can just use the default setup and it'll work pretty much out of the box. And we intend to sort of make Vue this more future-oriented because it only, currently it's designed to only support Vue 3. It only also emits ES 2015 plus code. So if you're targeting modern browsers, you should really give it a shot. Okay, so now let's get into the more interesting question on why did it take so long for Vue 3 to be released. As a matter of fact, it's still not released right now. It's still in the release candidate phase. And if you've been following along the Vue 3 development, you know that we announced it almost 2 years ago. So here's a timeline of Vue 3's development. The initial ideation, the high-level research and design actually started as early as back in February 2018. That's when I first had the idea, like, hey, maybe, like, what should we do if we were to build a next major version of Vue? Right? But around that time, it was not really a real process. It's really just like collecting thoughts and ideas here and there, trying to put things together and trying to sketch down what are the goals and what should we try to aim to solve in Vue 3. And those are really, really rough. And we had to do a lot of research just to get a better idea of where we are. So the first step that we decided, when we finally decided to get into writing some code, is in September 2019, where I started experimenting to rewrite the reactivity system of Vue using proxies, right? Because it's like 3 years after proxies are actually part of ES, the ECMAScript spec, it's finally starting to be available in most major browsers. So we feel like, oh, maybe it's time to actually start trying it out and see if we can really replicate the reactivity system using proxies. And turns out it works. So that's a very good start for us to go into actual early prototyping. And by prototyping, we really tried a lot of different things. We tried a class API, which we eventually dropped. We even tried something like time slicing, which is what React concurrent mode does. We tried a lot of interesting ideas, and a lot of them are also scrapped because we just didn't. Some of them just didn't prove to be worthwhile. Like you have to invest so much into it to get very small benefits. Some of them is we simply couldn't make it work. For example, the class API, we even built the initial version of Vue 3 using a built-in class API for components, but as we try to actually replicate all the features of Vue 2, we realized the class API just have so much limitations, especially back in 2018. There are a lot of the parts of the class API wasn't even finalized yet. For example, class fields, private fields, and also the behavior of class field initialization, decorators, which still isn't finalized today. Right? There were just so many uncertainties revolving classes that we eventually decided to just move away from it. And during that process, we also have to establish an RFC process, which we'll talk a bit about later. And we also had to work on Vue 2. We still had to release new Vue 2 features. We released Vue 2.6 in February 2019. And then starting in March 2019, we finally started to rethink how the rendering performance can be improved and came up with the compiler-informed virtual DOM idea. And then in June to August, we worked on the composition API, which mostly involves around writing RFC proposals, discussing with people on GitHub, writing really, really long feedback and debate with people on what's better, what should we do. A lot of discussion going on in this period. And we finally came to somewhat a stabilized proposal at the end of August. And then we finally get the chance to focus on just bringing Vue 3 and everything else into feature parity with Vue 2, which actually is also a lot of work. We have so many features like vModel, transition, and later on, just in Vue core, we have these features that we have to kind of catch up with Vue 2 and ensure that they actually behave the same as much as possible. Right? And in that process, whenever we feel necessary that we need to make a breaking change, we have to write an RFC and go through the process and discuss with people, make sure it's okay. And for every RFC, we have to come up with a migration strategy. Right? So finally, in January 2020, we reached the 3.0 alpha stage. And that's just sort of, the alpha is really just like we finally got the runtime, the client runtime to be have feature parity with Vue 2. And then we have to work on server-side rendering. which involves a new server-side optimizing compiler, which we just demonstrated. We have to figure out a way to make server-side rendering faster and more efficient using latest node features. Also have to design it in a way that worked with the new router and Vuex implementations, which was being worked on at the same time. So that took us another 3 months. And finally, in April, we got to the beta stage. And when we got to the beta stage, we realized, okay, so if we want to have this thing ready and be available for people to try out, we actually have to have all the toolings ready as well. So we need to have a CLI that allows people to scaffold and start a new project with Vue 3. And that is what kind of motivated me to work on Vite. And then now we work on tooling. Why not just throwing a few improvements on single file components? At the same time, the docs team had to sort of work on a big overhaul of our docs to pulling all the changes that we proposed from the RFC into the new version of docs. Make sure there is a migration guide for people who want to try out Vue 3 they can read. And then the rest of the ecosystem, like our ESLint plugin, our dev tools, our CLI, and everything has to be updated to sync with the new Vue 3 core. So that is, again, a ton of work. And so we finally reached RC stage just 2 weeks ago. So that was a really, really long and challenging process, to be honest. And that is specific. This whole timeline is specific to Vue. So I want to kind of quickly go through some takeaways on what that's more generic that would apply to a lot of other open source projects. Some factors that would affect the development speed of a major rewrite. The first is goals. The second is historical burden. Third is the scope of work. And finally is how open you want the design to be. So first, the goal is explorative versus well-defined. Some projects, when they work on a new major version, it's very, very clear that what they're going to do. They're like, we're just going to break this. We're done. So that's because it's breaking, it's going to be a new major version, right? So the difference between this and something that we would call a more explorative major version is a more explorative major version is going to pretty much bring in a lot of new concepts or bring in some new fundamental improvements. A good example to think about is Angular 1 going to Angular 2 versus later bumps like 2 to 3, 3 to 4, right? Angular 2 to Angular 3, 4, 5, 8 is really not that much different. It's just new major version with some breaking changes. I think Angular 8 to 9 is another sort of major internal rewrite, but 1 to 2 is definitely one of those super, super huge paradigm shifting kind of changes, right? And another aspect of this is major rewrite versus major redesign. So in the case of React 16, right, it introduced hooks, but the very impressive work that the React team has done is 16 still maintains largely compatible with all the legacy old class-based codes that you write. So it's kind of like changing the engine of a plane on during the flight, and it still keeps flying, right? So that's that's a very impressive work. But there are also limitations because you're kind of much more bound to the past design decisions. So Vue 3 is kind of somewhere in between where we are making some necessary breaking changes in order to facilitate some of the new benefits that we want to bring about. But we also try to be backwards compatible as much as we can in areas that don't have to change. So the historical burden part is how long has this project been around? Right? Vue 2 was released in September 2016, so that's how long? That's almost 4 years now. Wow, that's crazy, right? So during that whole process, a whole ecosystem, all these education materials that came out, people learned Vue, and to a lot of people, they've been working with Vue for like 3 to 4 years. To them, a lot of the paradigms are completely internalized, and they feel like this is how Vue is, and this is how Vue should work, right? So when you make a new major version, inevitably you're going to break some assumptions that was true in the past, but no longer true in the new version, and that's going to be challenging, right? And the amount of in production usage. We have over 1 million users worldwide. There are tens of thousands of production apps using Vue. So how would you want them to migrate? And how? So this is a very delicate balance, right? If you break too much, they'll probably never upgrade. But if you want everyone to be able to completely seamlessly upgrade, then you're placing so much limitation on the new design that some of the very beneficial new things you simply cannot do, right? So it's kind of a really delicate balance that you have to manage. And every design decision must be made with compatibility and migration strategies in mind. So that's where most of the challenge is. The design process takes so long because you have to think through every change that you make with all these factors involved. And on top of that, you still have to maintain the current version, right? There are still bugs being reported to Vue 2. And the scope, right? When Vue just started, it was just a small library. And if you have just a really simple library, even if you have a really complex library, but you have a relatively minimal API surface, rewriting the internals will be much easier as long as you keep the API contract intact. But for something like a framework like Vue, we've grown into something that's more like a full-size framework now. So every change that we make affects the router, the Vuex, the CLI, how JSX support should work, and all these toolings and all the ecosystem libraries that people have written, right? So the implication is much, much bigger for something like a framework. And this scope, this API surface, is directly correlated with the difficulty of all those design decisions that we mentioned just now. And internally, even in the development process internally, there is this dependency between the internal parts of a framework. Like we have to get the reactivity system ready first before we can work on the rendering part. We have to get the core ready before we can work on router or Vuex. And then we have to all of these ready before we can actually work on CLI integrations that put all these things together, right? So there is a cascading order that you have to kind of follow to do it step by step. And even if we have a team of multiple people coordinating this, because of this dependency order, it doesn't really necessarily mean you can like work on the core and the router at the same time. One has to be before the other, right? So, and finally, designing in the open. So this is the most challenging part, I would say, in working on open source. So we established the RFC process early 2019 in the hope, because when we are working on this new major version, we want the users to be aware. We want the users to be able to get involved in the process. So the process largely follows a draft that we sort of share inside the team for internal review. Then we go on, submit it to GitHub as a public proposal in the form of a pull request. Then all the discussion and revisions happen in that GitHub pull request. And as you can see, we have all of these merged pull requests on GitHub. And the most popular one has more than 300 comments. And imagine when we were working on Composition API, really, it was a very, very intensive process where there are like 10 to 20 comments added in a single day, and we have to reply to them, explain to everyone like how this works. And we sometimes even have to debate with people, because some people just strongly reject new paradigms being introduced to the framework, because they fear that this will change how everyone will use the framework, and then they have to change too. So so that brings me to the point about managing expectations, right? When you introduce something that's very big, that's very that challenges existing assumptions, there's going to be pushback. So it's actually quite interesting on how much design you want to actually do in the open before you present something for feedback. Because if you present a new, somewhat radical idea too early, you'll get so much negative feedback, it'll just probably die. But maybe that will end up being a good idea, right? That's one of the reasons the React team decided to work on the hooks idea completely in private, and it kind of revealed it to the world when it's kind of already said and done. Some people are not happy about that, but I think, hey, that's kind of necessary considering how paradigm shifting it is. And we kind of had to do that for the Vue Composition API too. And we were actually a bit too enthusiastic. So we revealed this whole idea as what we call the function API first, without thinking it through too much, and indicated that this may be a replacement for the current options API. And people just went mad, and we had a lot of pushback and negative feedback in that period, and we kind of had to step back, rethink the proposal, rework everything, and try to listen to the positive and negative feedback at the same time and figure out the best way forward. And that was a lesson to us. So so you don't necessarily want to put everything out there in the open. You kind of want to communicate it in a relatively subtle fashion so that you can manage the process without while keeping your own sanity. That's really the key. Right? So the challenge of consensus, the challenge here is even if you manage all these communication, right? When you have a big enough change, you simply can't make everyone happy when you have a large enough audience. Like for something like React or Vue, we have millions of users, and every single change you use, there's going to be a few people who are skeptical, who are indifferent, or some people will just outright be angry at you for making a design decision that they don't like. And it's a tough balance because you get all of these different feedbacks, and this signal versus noise ratio is it's not always accurately reflecting what the whole user base is really thinking, because you're only getting some of the loudest people in the room. And although it's somewhat representative, it's not accurate. So sometimes you just have to trust your guts, and you have to kind of take the balance between respecting constructive feedback, but still decide, okay, this is good feedback, but we believe you're wrong. Obviously, you don't want to tell that to their face. You'll say, we respect your opinion, but we understand this problem, and we believe this will end up being the better way to do things. Right? Sometimes you just have to make a call. Again, this is hard. There's no formula for this. You kind of just have to sometimes just trust your own intuition, trust your experience, trust your all the years that you put into the work. And sometimes maybe you'll just admit you're wrong. and take a step back and rethink everything and redo it. And that's what we did when we first came up with a functional API proposal, and we eventually reworked it based on community feedback, right? So all of this is pretty hard, but this is what true open source software is about, right? So I went over, but I hope all of this doesn't sound like me rambling about this, but open source is not just about putting some code out there. It's about building it collectively as a community. And in the case of Vue, particularly so, because Vue is not a side project, a side product of a for-profit company. It's not some megacorp just deciding to open source an internal project for people to use as a career marketing sort of thing. Vue is independent. It's completely built for the community. Its sole purpose of existence is to be a better framework for its users. So, and in order to achieve that, we have to involve the community in the process. Even if that means making things harder sometimes, we believe it's all worth it because it's what allows us to build better software in the end. And that's it. Thank you.
Okay, Mandarin time. 那各位好，我们现在那个。Hello， 好，那各位有没有什么问题？
我这边听得不是很清楚，声音有一点轻。
如果有人有问题的话，现在可以举手。有没有朋友要问问题？
那个我想请问一下，我想学那个 Vue 的话，请问一下 Vue 跟 React 差在哪边？因为我之前有一个活动在那个5倍红宝石有办那个养一个擂台的活动，你知道吗？
我在这里听得不是很清楚，我可能需要有人帮我把问题凑近一点，复述一下。
刚才我们的朋友就是想询问说 ，Vue 和 React 主要的差别是什么？
这个问题其实很讲起来会比较大，因为从整体的实现上来讲的话呢，这其实真的如果要真的讲，会需要讲很多，但是。简单的来讲的话呢 ，Vue 会更加的倾向于把Vue 更像一个框架，也就是说 Vue 做的事情会比 React 更多一点。然后 React 的话呢，像 Facebook 他们只专注于 React 本身作为一个 library， 所以很多的这些比如说你需要有路由 routing 或者是state management 等等，你可能会需要去 React 的这个 ecosystem 里面去寻找一些解决方案，然后你会需要自己去挑选比较，会需要做很多的这种自己搭建一个 framework 这样的工作。而 Vue 的话呢，相对而言我们会做的更多一些，我们会有一些官方的方案，官方的最佳实践，官方的一些整合，这样的话会比较省心一点。然后从设计里，就是一些设计理念上来讲呢 ，Vue 更加倾向于使用可变的数据，就是 mutability， 然后 React 会更加倾向于 immutability。这中间的区别呢，因为几句话实在是说不清楚，但是大致上而言 ，Vue 选择走 mutable 路线的根本原因，是因为这样会更容易做。用户不需要用户去亲自做的一些优化，给予我们一些更多的性能优化的空间。就是尤其是在大 大型的这个应用中会有很深的组件嵌套的情况下，Vue 可以利用精确的数据追踪去做更精确的，就是组件更新触发的这些处理。而 React 因为它采用这个整个的一个比较从上往下的一种更新模式，会导致就是会有更多的时候它这个作为框架层面，它没有办法做一些很安全的这个所谓的 assumption， 就是因为它的这个数据更新方式导致 React 可以 safely， 不太确定这个中文怎么讲，就是 safe optimization 的空间会比较小一点但是呢，他们 React 现在走的路线就是说，它放弃了这种微观层面的优化，而是去走宏观层面的进行这种对你的对一些更新进行宏观的调度，也就是 React Concurrent Mode 现在在走的路线，而 Vue 走的更多的是一种从就是也不是说微观吧，而是走的一种从根本上减少无谓的更新来提升性能，而 React 就是说，它已经等于说默认了你会有很多无谓的更新，所以我们会需要通过调度你这些更新发生的时间来规避这些性能问题。这从本质上讲，就是现在我们走的这两个非常不一样的路线，但这个属于是非常技术层面的区别。如果是仅仅是从用户体验的层面上来讲，主要就是一个 library versus framework 这样的一个区别。Vue 会更加专注于上手的亲和度，更加注重于提供一个比较就是说任何人都可以快速的学习、快速的参与开发的这样一种体验而不需要去学习过多的这种社区的一些已经形成的比较高深的这种技巧，如何使用 higher order component 这类的技巧，然后你才能说我是一个 React developer。Vue 的话，一般来说你开完账就可以说你会 Vue 了这样。
好的，谢谢 Evan。我们现场还可以再开放一个问题。
Hi Evan 你好，我是 Vue 这次台湾的 Crew。那在这边我想要问几个问题就是我们都知道说在 Vue 1跟2的时候，我们它的型别其实是用 Flow.js 嘛。那在 Vue 3的时候换成了 TypeScript， 那可以讲一下主要的原因吗？那以及另外我们知道说最近您有开发这个 Vite， 那我们想要知道说 Vite 跟原本 CLI 的这个 Webpack， 那为什么你会想要开发这个 Vite？ 那它主要的目的是什么？谢谢。
第一个问题是关于 Flow 和 TypeScript 对吗？
是的。
对关于从 Flow 换到 TypeScript 呢，我演讲里面也大概提了一下，主要原因是因为 Flow 作为一个 Facebook 的项目，它对于社区的这个反馈并不是很上心，它并不是很积极的想要把它做成一个社区的项目，它主要还是以服务 Facebook 为主，所以很多用户的需求它并不是很在意。而且就是说对于这个一些然后因为现在大家很多都用 VS Code， 然后 Flow 跟 TypeScript 在 VS Code 里面的整合还是 TypeScript 会有很多优势，因为毕竟是同一家公司的再加上 TypeScript 呢，确实对于他们TypeScript 团队对于社区用户的这个需求会更加的在意一点，不仅仅是服务微软本身。我跟 TypeScript 团队他们的那个 Program Manager， 其实他们会有主动过来跟 Vue 去跟我们来谈，就是说有什么需求，就是你在用 TypeScript 遇到什么问题，他们会试图帮我们解决。所以整体上而言，就是其实很大一部分程度上是因为 TypeScript 更加的一个为社区而做的这样的一个项目，这其实是一个很重要的原因。然后纯技术方面的话呢，其实两个类型系统，如果你要真的去比较类型系统，其实各有所长。但是真的是从作为一个非微软的一个外部的用户去使用的话呢，整体上我觉得 TypeScript 还是更加会在意我们这些用户的感受，主要还是这样。然后另一方面，就当然也是 整个社区层面，就是 TypeScript 现在的使用人数显然也比 Flow 要多。那我们作为一个框架，我们如果要去支持一个类型系统的话，也有越来越多的 Vue 的用户在用 TypeScript， 相对而言用 Flow 和加 Vue 的用户很少，几乎没有。所以对我们来说，切换到 TypeScript 就是一个比较自然的一个决定。另一个问题是关于 Vite。Vite 是一个Vite 的主要的一个出发点是利用浏览器原生的这个 native 的 ES modules 这样的一个特性，就是如果你在嵌入一段 script， 然后你的 script 标签如果加上 script type equals module， 那浏览器会发出一个原生的ES module 的请求，然后也就是说你的这些 ES module 的这些语法，它是完全是由浏览器去进行 parse， 然后浏览器去发出 HTTP request， 然后转回到你的浏览器里面。那这样的话，我们现在习惯的前端开发大部分是要通过打包这一步也就是说，你比如说你写了 import something from something， 先要打包，把它打包成一个就是把这些 import 的语法全都被处理掉，然后打包成一个文件，然后再交给浏览器，然后浏览器就可以运行。但是如果你不把它打包，而是直接让浏览器去进行自然的这些就是 module 的翻译，那这样的话呢，其实效率会比先打包再发过去会更快一点，因为先打包再发过去其实也是需要很多时间，就是需要有一个工具去读取你所有的文件，还要对你所有的文件进行 parse， 而且这些 parse 通常这些 parser 也是 JavaScript 写的，而不是浏览器里的原生的 parser， 所以浏览器原生的 parse 你的 JavaScript 会更快，然后它fetch这些文件效率也很高，因为是在本地的磁盘上，而不是通过网络，所以整体而言，就是我们可以完全跳过打包这一步，在开发的过程中不需要再考虑打包这个问题。那所有的这些编码的转换，就是比如说你需要把一个非 JavaScript 的文件去编译成 JavaScript， 这一步可以在浏览器发出这个请求，然后你在服务器端起一个本地的服务器，然后本地的这个服务器可以在收到请求的时候即时进行编译，就是 just in time。这样的话你就等于可以完成一个打包工具能够做所有的事情，但是你不需要进行打包这一步，所以性能会很好。然后在基于这个基础上，如果再做这个hot module replacement， 就是热更新的话，性能就会非常非常的高。其实主要还是一个让开发体验变得更快的一个项目。所以如果你去体验一下同样一个，比如说如果你用 React， 然后你用 React 去创建一个新应用，然后你用 Vite 也创建一个一模一样的应用，两个用的源代码一模一样，但是你会直观的感受到 Vite 的这个更新速度和编译速度都要快上一个数量级，所以主要就是一个开发时的体验的一个改善。
这样可以有回答啊？好，那由于时间的关系我这边刚刚还有一位想要问问题，那我们就带到外面去继续问。那这边的时间我要先还给这边的主会场，因为我在这边再问一个那先跟大家说一下拜拜我们后面还有一个问题，但是先跟大家说一下拜拜，因为那个主会场的摄影机要先关掉。
谢谢大家。
好，谢谢。好，那就是。